Hello viewers, welcome once again. We are still under logic, Christ Almighty God's Algebra. Last tutorial we treated second Ejike's law by conjunctive statement. Today we are going to treat second Ejike's law by disjunctive statement. Let us start. Second Ejike's law. P or brackets, not P and D, Q is equal to P or Q. This is a typical example of second Ejike's law by disjunctive statement. If you look at this equation, you will find out that it is logical equivalent in the sense that whenever the left hand of the equation is true, also the right answer of the question is also true. In the same vein, whenever the right answer of the question is false, also the left answer of the question must also be false. We say that the equation is a logical equivalent. Why is it called second Ejike's law by disjunctive statement? Is because of or connective that combines P and the Q together as a statement. So this or now that connect them together makes it to be disjunctive statement. That's why we call it second Ejike's law by disjunctive statement. Let's prove the statement that it is second Ejike's law. Proof. Suppose P or bracket not P and Q is equal to P or Q. We assume that the statement is true. That means P or bracket not P and Q is equal to P or Q, and its hypothesis. You will find out that the equation is a logical equivalent in the sense that whenever the left answer of the equation is true, also the right answer of the equation must also be true. In the same vein, whenever the right answer of the equation is false, also the left answer of the equation must also be false. We say that it is logical equivalent. Since the equation is logical equivalent, we can transform it to biconditional statement. If and only if P or bracket not P and Q, if and only if P or Q. We have now transformed it to biconditional statement, and we find out that whenever the left equivalent is true, also the right equivalent must also be true. In the same vein, whenever the right equivalent is false, also the left equivalent must also be false. So whenever we want to validate this statement, there's no possibility of getting falsity, always truth. We say that the statement is tautology because there's no possibility of getting falsity when we want to validate the statement, always truth. We say that the statement is tautology. logic is tautology being justified by being justified by logical equivalence. Being justified by logical equivalence. Being justified by logical equivalence. Since this particular statement is tautology, we can also transform it to bipropositional statement and it will still preserve tautology. So if and only if P or bracket not P and Q implies P or Q. We have now transformed it to conditional statement. And whenever antecedent is true, also the consequent must also be true. In this case, whenever you want to validate the statement, there's no possibility of getting falsity. Always truth. We say that statement is tautology. Is tautology. Being justified by logical implication. Being justified by logical implication. See, this question statement is tautology. We then deduce that antecedent exists. That means antecedent is a proper implication of the consequent. And if it's something that antecedent exists, we say that it is logical implication of the consequent. If and only if P or bracket not P and Q is logical implication of P or Q. So the P or bracket not P and Q is logical implication of P or Q, I mean the consequence. So if this is true, also this must also be true. So if and only if P or bracket not P and Q is equal to P or bracket not P and Q. That means the logical implication is equal to itself. And if it's equal to itself, it's logical equivalent. It is true that it's logical equivalent. That means whenever the left-hand side of the logical implication is true, also the right of logical implication is also true. In the same way, whenever the right-hand side of logical implication is false, also the left-hand side of logical implication is also false. We say it is logical equivalent, and it is true that it is logical equivalent. Being justified by identity, the same less. By identity, that is the same less. If and only if P or brackets not P and the Q is equal to not P and the Q upon not P. We say it is not, it's equivalent to say that it is not P and Q upon not P. That means that not is equal to each other, is equal to each other, because when you evaluate this thing, when you evaluate it using two table, it will find out that it is equal to the left side of equation. So be justified by first Ejike's law, because this is a disjunctive statement that being transformed to conditional statement by first Ejike's law. Being justified by first Ejike's law. So if and only if P or bracket not P and the Q is equal to not P upon not P and Q upon not P. We have now distributed not P, that the implication between not P and the Q. That's why we have not P implies not P and not P implies Q. That means not P upon not P and the Q upon not P. Being justified by distribution of implication. By distribution of implication. If and only if P or bracket not P and the Q is equal to, we are going to revise this conditional statement to disjunctive statement. Reason why we want to revise them to disjunctive statement is the implication not P is being generated from disjunctive statement. This P or bracket not P and the Q. So the implication not P is being generated from this disjunctive statement. So whenever I want to revise it, since that's from conditional statement, so whenever I want to revise it, it's going to be in disjunctive statement. That means we have bracket not P or let's say P or not P and bracket P or Q. P or Q. Being justified by first Ejike's law. First Ejike's law. So if and only if P or bracket not P and Q is equal to bracket. This P or not P is equal to tautology. That means equal to T is tautology. And P or Q. You see that this P or not P is equal to T being justified by law of complement. By law of complement. By law of complement. So if and only if P or bracket not P and Q is equal to, whenever tautology is handled with any term is setting as that term being justified by law of identity. That means it's equal to P or Q being justified by law of identity. We have now proved that P or bracket not P and Q is equal to P or Q. That means P or bracket not P and Q is equal to P or Q. We then conclude, say thus P or bracket not P and Q is equal to P or Q. Now, since the statement is logical equivalent and it is law, we are going to prove the converse so that we can establish by the principle of sexuality that P or bracket not P and Q is equal to P or Q is second Ejike's law by disjunctive statement. Let's continue this side. So conversely, P or Q is equal to P or bracket not P and Q. We have seen that this P or Q at the right answer question here has now become P or Q at the left answer question here. Then P or bracket not P and Q at the left answer question here has now become P or bracket not P and Q at the right answer question here. That means is converse. Let's prove the converse. Let's suppose P or Q is equal to P or bracket not P and Q. We assume that the converse is true. I mean, it is true that it's logical equivalent. That whenever the left answer question is true, also the right answer question must also be true. In the same vein, whenever the right answer question is false, also the left answer question must also be false. We say that it is logical equivalent. Since it is logical equivalent, we can transform it to biconditional statement. Say, if and only if P or Q, if and only if P or bracket not P and Q. You will find out that you have not transformed it to biconditional statement. And whatever the left equivalent is true, also the right equivalent must also be true. In the same vein, whenever the right equivalent is false, also the left equivalent must also be false. So whenever we want to make statement, there's no possibility of getting falsity, always truth. We say that the statement is tautology. Is tautology. Being justified by logical equivalence. Being justified by logical equivalence. If and only if, now see this statement is by conditional statement and is tautology. But you can also transform it to conditional statement and it will still preserve tautology. That means P or Q implies P or bracket, not P and the Q. We see that whenever the antecedent is true, also the consequent must also be true. So whenever we want to make statement, there's no possibility of getting falsity, always truth. We say that the statement is tautology. Is tautology. Being justified by biological implication. Now see this question statement is tautology. We then deduce that antecedent is logical implication of the consequent. That means it is certain that consequent the antecedent exists. That means it is a proper implication of the logical of the consequent. And if that is the case, he said that the antecedent is logical implication of the consequent. So if and only if P or Q is logical implication of is logical implication of P or bracket, not P and the Q. So we have now deduced that P or Q is logical implication of P or bracket, not P and the Q. So if this is true, also this must also be true. Let's clear and continue. If and only if P or Q is equal to P or Q. That means the logical implication is equal to itself. And it is true that it is equal to itself. And if logical implication is equal to itself, it means that it is logical equivalent. And it is true that it is logical equivalent. Because whenever the left-hand side of the equation of logical equivalent is of the logical application is true, also the right hand side also must also be true. Whenever the right hand side of logical implication is false, also the left hand side of logical application also must also be false. If that is the case, so that it is logical equivalent and it is true, being justified by identity, that means the sameness. By identity. If and only if P or Q is equal to bracket not P and G, Q or bracket P or Q. Now we have made, it's not P or P. Now we have made not P and P a disjunct of the P also of this statement P and not P or P or Q. You find out that this not P and P is equal to falsity, and what falsity is all we terminating at that term. So it's still logical equivalent. It's still preserved logical equivalent. So being justified by law of identity. By law of identity. So if and only if P or Q is equal to P upon P or bracket P or Q. You find out that we have now transformed this not P and the P to that is in conjunctive statement to conditional statement by Christ the Almighty God's grace. And the statement, this equation is no more logical equivalent, because now the right hand of the equation is now greater than the left hand of the equation. We say it's now grace, no more law, because the right hand of the equation is now tautology, greater than the left hand of the equation. We say that is intensification of P or Q being justified by Christ the Almighty God's grace. So if and only if P or Q is equal to P or bracket P upon P, P upon P or Q upon P. You see that this not this P, this implication P has been distributed between P or Q. That's why we have P upon P or Q upon P, because this P has been distributed between P or Q, and is still intensification of P or Q. I mean, is still intensification of the left hand side equation, because the right hand side equation is still greater than the left hand side of the equation. That means it is still tautology. The right hand side is still tautology. That is greater than the left hand side of the equation. We say is intensification of P or Q. It's intensification of P or Q being justified by distribution of implication. By distribution of implication. Say if and only if and only if P or Q is equal to P or bracket. Now we are going to transform this P upon P, this conditional statement, P upon P or Q upon P, to disjunctive statement, because this P, the implication of this P is being generated from the conjunctive statement. That's why when you want to revise it, it's going to be in conjunctive statement. So we're going to revise it to conjunctive statement, because the implication is being derived by conjunctive statement. So we are going to have P and not P, or bracket, not P and P, or not P or Q. It's now equivalent to left hand side of the equation now. It's now logical equivalent. No more grace. It's now law. Being justified, this is and. Being justified by Christ the Almighty God's grace. So it's through the great Almighty God's grace that we used to transform it to conjunctive. These statements, these conditional statements to conjunctive statements. We continue to this side. So if and only if P or Q is equal to P or bracket, then this not P and P is equal to F. It's equal to contradiction. That means F or bracket not P and Q. Not P and Q. Is still logical equivalent being justified by law of complement, because this not P and P is equal to F being justified by law of complement. So if and only if P or Q is equal to P or bracket not P and Q, because when falsity is always terminating as that term, that means F or bracket not P or Q is equal to not P, not P and Q is equal to not P and Q. Being justified by law of identity. You have seen that you have now proved the converse. You have now proved the converse because this P or Q ID right answer the question here has now become P or Q ID left answer the question here. Then P or bracket not P and Q ID left answer the question here has become P or bracket not P and Q ID right answer the question here. We then conclude say thus P or Q is equal to P or bracket not P and Q. We have now proved the converse. Since I have now proved the converse, by the principle of reciprocity, we then establish that P or bracket not P and Q is equal to P or Q is second Ejike's law by disjunctive statement. Therefore, P or bracket not P and Q is equal to P or Q is second Ejike's law by disjunctive statement. So we have proved that P or bracket not P and Q is equal to P or Q is second Ejike's law. So at this juncture, we withdraw our curtain. Thank you, viewers.